So thank you for turning up to this talk. I know it's the last one, so people probably want to go home. So promise, or I'll try to promise to make it a little bit interesting at least. So what we're talking about today is data engineering or modern enterprise data engineering. I just want to ask a question first of all. How many people here have heard of DataOps? Hands up. It's amazing because I asked the same question on this stage this time last year and 3 people put their hands up. So at least people know what I'm going to be talking about this time around, right? So getting into sort of data engineering, this has come out of the whole idea of DataOps because we started off talking about, it's a process. And where it's originated from, DataOps as a process, is if you think about software engineering and how products are being built more often now, the process is so much more slick and automated in terms of bringing out what we look at apps on our phones these days, or even enterprise products that are coming out that are being used by large organizations. It's quick, it's fast, a lot of automation has been put in. And originally when there was a set of companies, and Tame has been one of the first ones to look at this, when we looked at DataOps in the first place, is we looked at how can we simplify and get data out to end users as quickly as possible. A lot of it was focused around process. What we forgot about were the people that were involved in trying to bring the data out. And traditionally, when we talk about the people, they tend to, we've got this ideology that it's people who either are DBA type of people or data scientists. Actually, there's a myriad people in between that are involved in the process of getting good quality data out that can be used and value can be determined off the back of it. So one of the things that we talk about quite a lot, and as you will see out there, the message out there is all about AI and machine learning. And a lot of companies and enterprises are tempted enormously to put the AI or ML cart before the horse. What we're talking about there is generally, let's go and get some tools that have AI and ML built in and forget about what actually powers all of that, which is the data itself. And that's been one of the one of the key things that we've seen in organizations. People are ready to invest in tools and technology and in people, but forget about the data itself. Data engineering is foundational. The terminology used here, everybody's heard of it, garbage in, garbage out. When we look at it, when we divide it down into what is done today, when we look at people asking questions, analysts, third-party consultants, they tend to just want to know the answers to questions that are being asked. How many customers do you have? A simple question, very tough to answer. Because if you ask finance how many customers the organization has got, they'll give you one answer. If you ask sales how many customers that you got, they'll give you a second answer. Depends on what a customer is. When we look at data scientists these days, the reality is value is not being extracted out of the skill set that they've got, purely because they're having to do a lot of the janitorial work, which is cleaning up data, as opposed to the stuff that really what they want to do, which is build the models, look at the statistics, the visualization, and the analytics around the data itself. Data engineers, generally when we've looked at data engineers, what people have talked about, we've tried to sub in people who've got their jobs already, which is DBAs or people looking after systems. Again, they're into the IT part of the technology. They may not know the data as well. So that's generally the challenges that we are looking at. What's the difference between data science and data engineering? There's a big overlap when it comes to skills and responsibilities. But there's a big difference in terms of what value they bring and what their roles entail. When you look at data scientists, their key sort of metric that they're measured on tends to be around reporting visualization, statistical modeling, machine learning, not around data movement, data cleansing, or the performance or optimization of databases. That's really a data engineering role. And it's important when we look at organizations that we look at it as a team. There's many members of a team, get them together and you get a fast, effective way to operate and way to bring out data apps that are important to the organization. So who's doing what? we've got the data suppliers, and generally they tend to be the hardest people to get hold of. People that own the systems, source systems such as CRMs, DBAs, or the IT part of the business. You have the data consumers, the data citizens, people that are using the data on a day-to-day basis, creating the reports, the visualizations, or reporting up to senior levels, or the senior level themselves. The bit that we're missing at the moment, or we're trying to address, is the data engineers. The curators, the stewards, the people that understand movement of data from system to end user. When you look at companies like Netflix, they've done this really well. I mean, they're a newer company. They've been born with data at their hands, but what they provide is portals for people to use, where the engineers have built these portals for end users to be able to do analytics very, very quickly. So organizations such as Netflix, even though people think of this as a new company, I mean, originally they started off selling DVDs, right? Or renting DVDs. So they started off in a traditional world, but what they did was bring together data very, very well, and set up things like DataOps and this DataOps pipeline for people to be able to use. Hence, they've been successful very quickly. Some of the customers that we've worked with or we know about, all of them, regardless of what industry they're from, have got the same data challenges and actually are looking at using the same mechanisms, even though the use cases are very different, to be able to bring together data to use it better. As you can see, some of these companies are very, very traditional companies, been around over 100 years. Some of them are new, but still trying to modernize their sort of data enterprise network that they've got. Why is it so difficult? Well, many of you have seen variations of this slide, and it has its many guises. It's sort of the way the data is connected together. We tried to address this a while back by moving from databases to a data lake. Many of you will hear the term, the data lake is now a data swamp. But the challenge is you've got things like politics, mergers and acquisitions, data hoarding, restructuring, or just a legacy in place, the legacy burden from systems, which causes some of these challenges that organizations have got today to bring their data together. So the consequences of this is the amount of time spent on data prep versus data analytics, the high rates of failure when it comes to business intelligence projects and analytics projects, and just people giving up after a period of time because people just don't want everybody to have access to data. Another company that does this really well, Airbnb. As you can see, well presented. You've got the sort of the metadata on one side. People recognize this from Wikipedia. And then the key attributes of the data on the left-hand side. So it's really easy to pin what you want from the data very, very quickly. And ultimately, every organization can do this because we've got the data available for us to be able to do this. And the big challenge that we have is behavioral. Right, it's humans. It's the sort of the being afraid to share data or hoarding of data. The other challenges, which are not just human, are around data complexity, privacy, and you have got sort of limiting that data to small numbers of people that are actually using the data itself. Yeah, this is an eyesore. Sorry for this, but this is what you're dealing with today. And actually, it's an example of what you see out there. Everybody has the same message, right? Everybody's doing AI. Everybody's doing machine learning. These are the technologies that you're being presented with today, and you have to walk through each and every one to work out what's right for you. A DataOps pipeline consists of a number of different things. A lot of the people, and we're part of this, will say we can do all of it, or we can do some of it. And the important thing is being able to navigate through all of this, the noise as I call it, to get through to pick the right ones which will represent a great data pipeline. To give you the examples in your organization of what companies like Netflix and Airbnb have done, or Wikipedia have got already. So how can you do this? What's a creep? Everybody knows, everybody has the source data sets, whether it's Excel sheets, CSV, tabular systems, SAP, CRM system, whatever you want. We're also starting to engage with external data a hell of a lot more. Whether it's from places like Dun & Bradstreet, Thomson Reuters, or scrape data. So you're getting lots and lots of information from different places. But the key sort of components of data engineering and data ops are around governance, mastering and data quality, around movement, catalogs, being able to publish that data, storage and compute, and a feedback loop. So having a human involved who's updating as that data is changing on a regular basis. Other methods that we use for data engineering, it's really important. We look at the traditional methods that have been used, which have, in my opinion anyway, have failed in particular ways. But when we look at standardization, that doesn't work all the time. Trying to get this perfect model, well, we can be here for years trying to get the perfect model. We've been trying to do this for the last 20, 25 years. It doesn't work. Let's work in small bits of work that we can do and not have this one schema to rule them all, right? Aggregation. When we're doing aggregation, it just creates more silos, more sets of data, and we forget about the granularity when we're looking at that data. Federation, which creates performance challenges. MDM, which we talk about, extremely important, but let's look at a modern way of doing MDM and not the very, very traditional, let's get everything in together and boil the ocean when we're doing this. Looking at rationalizing systems, single vendor versus lots of different, the slide I showed before, that's lots of multiple vendors, but actually what you'll find is there's going to be a stream of people who say, we do all of this, right? Yes, people can do all of this, but they may not be able to do it right in that particular way. And just throw bodies at it. Traditional rules, time consuming and hasn't worked. So some of the key sort of processes and tools that we talk about anyway and we think are really important are putting cloud first. Everybody knows in terms of even the most traditional banks and organizations that we've got in the industry today, in industries today, are moving to the cloud. It's happening, or it's already happened. And when we look at the big vendors like Microsoft and Google and AWS, they're getting a fair share of those vendors moving there. So cloud's really, really important. As are a number of sort of different areas here. We should be able to build creative apps using these kind of processes in the data ops world, very quick, very fast, to get the word out there, and we can do this and do this really well. As I said to you earlier on, the question asked, data ops, is it a thing? Well, Wikipedia's got an entry for what it's worth, but it is becoming a big movement, and it's becoming and the data engineer is an important part of that particular movement. So what's the value of you expect from a data engineer? Well, we look at chief data officers in the same ilk as a chief financial officer, except for a chief financial officer is looking for a return on assets, and a chief data officer is looking for the return on data, right? It's the value you're getting out of it. They tend to look for things like analytics and information. Where is the data coming from? Where are my sources? How many employees, parts, products, contacts, and customers do I have in an organization? And in our ideal world, this is the outcome that we're looking for. This is very similar to what Airbnb and the pages I showed you before. It's the metadata about your data, which then can be drilled into and used by different individuals. It's transformational. A lot of people have a lot of source systems where they've got the same data residing in all of those source systems. So mastering some of those source systems to understand your before and after is extremely, extremely important. And of course, salespeople are looking for distribution by sales or different types of analytical outcome, and that can only be done after you have cleaned that data up and transformed that data. And why is it important now? Well, 7 years ago, everybody wanted data scientists. Literally everybody out there, and it was the best job to go and get. And we've got these data from elsewhere. If you look at the job listings for data scientists over the past sort of 7 or 8 years, they've gone up significantly. So now we have data scientists. But what we're asking them to do is mainly janitorial work, which is clean the data up. That's not their role. We need to have people who are specialized and skilled in that particular role to do that job, and that's why we need data engineers now. And it's a unique moment. We've got, the landscape of technology is changing. ML, AI, this is coming in, and it's becoming extremely useful. The way that the data is, where it's residing is changing. We're using cloud computing a lot more. And organizations are finding that data is extremely important to those organizations. It's an asset. They're agreeing to this. So you're getting economic buy-in from the people at the top. You're getting the tools, you're getting process change, and now is the time for us to take that particular action and make that particular change. And a lot of the Global 2000 companies out there are realizing this and making this change within their organizations. And I just want to leave you, I know time's running out and I want some questions, but what not to do when we're doing data engineering. As I mentioned before, let's not boil the ocean. Let's not go back to traditional sort of habits that we've formed in terms of delivering projects. Boil the ocean, waterfall. Let's try and be agile. Let's not think that one systems or one single platform is going to solve the problem. That's not what DataOps is about. It's using the best of breed for an individual task. There's a lot of, as I showed you the ISO slide, there's lots of technologies out there that you can try. Let's not stick to single vendor and think about bringing the best of breed together. Don't underestimate the effort required. As I said, as it says here, just because Google doesn't do it, it doesn't mean it won't work for you. Try something that works for you as an organization and not look at other people when we're doing this. Don't underestimate the behavioral change that will be required in an organization when you want to introduce these methodologies. And, avoid that kind of, data scientists are data engineers really, that kind of hubris around it. It's two different roles. You cannot get two people doing the same role. You let them do what they're really, really good at. And what's next? With the opportunity we've got, we can create great outcomes for our organizations. We can create great sort of repositories where people can start using data well, and everybody can start using it. We're consuming, as individual consumers of systems, a lot more data than we ever did before. And that should be available for everybody within your organization. And there are great technologies out there to be able to do this. That's it from me. Any questions? I'm happy to answer them now, or you can come to our booth, which is just down the aisle here. But if there's any questions, I'm happy to take them.